Okay guys, so we've been looking at integrals and I want to talk to you about how to figure out the area between two curves. Okay? So once you know how to figure out the area between two curves, we can then rotate that area around our axes to create a 3D figure. Okay, so we'll deal with that more next week, but right now we're just looking at the area between two curves. So for example, if I have some parabola pointing upside down, and I can say my equation of this parabola is f of x is equal to negative x squared plus 3x plus 10. And then I have another curve, or in this case a line, so something that looks more like this. Okay, and I want to figure out the area between these two curves. So my goal right now is to figure out this area here. Oh, and I forgot to tell you, the equation of that line is f of x is equal to negative x plus 8. So essentially what I need to do is figure out the area just under my parabola. So if I do that area in yellow, so I need to figure out what this entire area would be, okay? And then I need to subtract the area just from the line, okay? So I need to subtract that, and then I'd be left with the area in green. So hopefully you hear area under a curve, and your first thought is, okay, I need to take the integral, okay? So I need to take my integral of my first curve, so negative x squared plus 3x plus 10, this negative is kind of weak, dx, okay, right, because that's going to give me the area of my parabola, and then I need to subtract it from the integral of my line. Okay, now our integrals, hopefully you guys realize, are missing something, right? I don't have, these integrals need to be defined because I don't want the area of the entire curve. I just need to look at the area based on where those two things intersect, okay? Otherwise, I'll be including all this negative area here, and I don't want that. I just need the points where they intersect. So hopefully you guys remember how to use the intersection function on your calculator. So just as a quick reminder, you can graph both of these functions, one in y1, one in y2, and then once you're looking at the graph, do second calculate and select the intersection tool. Okay, and that would give you these 2 points of intersection right here. So I've already done that, and I found that my point of intersection on the left, so that gave me that this point right here, this point of intersection is this, negative 0.045, comma 8.441. Oh, I'm sorry, 449. Okay, and this point of intersection on this side is 4.45, comma 3.551. Okay, now if you remember when we first started talking about definite integrals, meaning we had values up here and here, we defined them from A to B, okay? And those A values and those B values were based on your intervals of x's. So even though we found our y coordinates here, we don't actually need them to define these integrals. So we can go ahead then and write our x coordinate, our first one as A, and our second one as B on both of these integrals. So that will give me, for the first one, I'm integrating from negative 0.45 to 4.45, and same thing on this one. Okay, and then we're going to take the integral the same way you guys have been doing the whole class at this point. So when I take my integral from my first function, I would get negative 1/3 x cubed plus 3/2 x squared plus 10x, and I would integrate from 0.45 to 4.45, okay, minus negative 1/2 x squared plus 8x. And again, I would evaluate that from negative 0.04, sorry, too many zeros. Negative 0.45 to 4.55. Okay, sorry, I think I misspoke. This is 4.45, not 4.55. Okay, now we can do this on our calculator and get the answer. The other thing is, guys, you could have also done this actually entirely in your calculator if you remember how to do the second, I think it's math 8, I think is that one, where it asks you for the integral. So especially on problems like this, you're not going to get it wrong to do a shortcut and plug it into your calculator, okay? Do that. It helps you. It saves you time, okay? Don't make your life harder than it has to be.